Okay, so tonight we're going to continue on for what we did last week regarding particles. Now, this is kind of, I don't know if this is not the exact file, but if you recall last week, we generated particles and we made them visible by using the material. And on the object here, I think it was on our Redshift tab, we had render object as particle. So then when we went to the Redshift, the Redshift render view, you got particles, which we were then able to render out and bring in using the .rs files and bring into Cinema. So, but suppose you don't want just these circles, you want something else. You're going to need instances. So let's look at that. So let's open up this file. And let's have a look here. As you can see, we do have our spheres coming out, but in this case, let's look at our source particles. We're merging we're bringing in the sphere, and we're bringing in our AutoDOP network, and then we're copying the sphere to the points generated by the AutoDOP network, starting with the pop object, which, if you look at the definition of a pop object, it converts a regular particle system into dynamics, a dynamic particle system, which, although not at this point, you're not going to have collisions, can interact with other objects. So we have this, and we can render, we don't have to render it in any special way because we've already got the objects. And in fact, so we have our sphere object here, which is very simple. Let's bring in let's see, what do we have in terms of create? We go to the create, we got a box sphere, a tube, torus, and grid. So let's bring in a tube. And we got this tube here, which is huge. So we're going to bring it down. Let's see what we got here. We're going to go in here, and we're going to give it, we're going to bring the scale down quite a bit here. And let's see if we can bring down the height quite a bit here. Bring it down some. So let's make little tubes. So now what we're going to do, kind of a skinny tube. Let's see if we can, let's put some end caps on it, make it look more substantial. And let's see what that's going to do. All right, so now we can go back here, and in our source particles, we can replace this and go back. And now we have tubes. Oh, let's put this We have lots of tubes. Now the problem here is these are not gonna, if you put a static object down here, a collision object, it's just gonna go right through it. So this will give you actual geometry, but it's not going to give you the collision. For that, you need a RBD solver. So let's bring in another file. Let's see what we got here. What we have here is I think this is the right one. All right, I think this will. Okay, see, now we have collisions. Now, how do we do that? Well, I did a lot of experimenting because I didn't love the ways that I see, and I may do some more. But the way that it seemed to work is, let's bring this up here. So we have our torus object, which is what's going to be our particles, and this is very simple. We have a grid object, which is I think that's going to be our static grid. In the sphere object, which is the source, we have it going to a scatter, which is going to put the points, how dense or how many points. I did it by density. And then we're doing attribute randomized by color. And now we have our torus here, which is what we are going to copy it to the points. So we have our torus being copied to the points generated by the sphere. Assembled. This is important because what we're going to do in this DOPNet wants, or the rigid body solver, rigid body dynamic solver wants packed object. Assemble will give it to you. So if you look right here, you have the packed objects. 39 primitive. Let me see something. When we do assemble pack fragments, and before here, when we just do this, we don't have any pack fragments. So this DOPNet wants this rigid packed objects. We have our populus. Now what this is going to do is, this is how we're going to generate the particles. And it's taking the first contact geometry, which means the first item in this, first item coming into here. And what we're going to do then is, this is where you control. Now, this is what I don't like. Because we're doing it the way we're doing it, we don't have we don't have the full control like we would normally, because we're going to rigid body solver and not a pop solver. But we can control the impulse action. This is something I saw in another tutorial. You saying that we're going to have an impulse every fourth frame, I believe. So it's one This is frame mod 4. And we also control it by the number that we scatter, the percentage we scattered on the source that we saw earlier in the sphere object right here. So the scatter. So we have two. It's not as, I don't like that as much. It's not as clean. And so then this goes into our .NET, where we have our rigid body solver. We merging it with the ground plane. And I used a stack object because I was not seeing the ground plane. And the ground plane is really more the dynamic. The grid is really more for visibility. Merge it. We have our gravity and we have our output. So what the result is these particles coming down, and let's have a look at what we got. So again, I am using a material. For some reason, the ground plane material isn't doing exactly what I want, but we have let's see, we have two different colors. I believe we're doing the regular one on the, let's see what we got here. So on the torus, we're using the regular. Now let's look at what that looks like. So we got user data color, because remember you see all these different colors. Splits it up to put it in a, make a color. So we have the data, we then create a color. We put it into a noise, into a ramp, and then, so very simple material. We're going to go to our Redshift render view here. And now you're going to see, takes a little bit, we're going to see, let's change this. This is 250, I don't know why it's 255, but it is. So let's make that 100%. And you can see we have our different particles based on our ramp and the input colors. But you can see, notice this is very important, that there you actually have collision, and we can look at it. If you look at this, let's start it over. Well, let's get the picture out first, and you can see we have here collision. I'm actually going to save this out. Save image as. You can do that. Okay, so this is going to be an EXR particle out. You can just save it. And let's close that. But you can see when we start, it's just dumping. Now, why the color changes to black after a while, I'm not sure. It would depend on how I'm generating the colors. So, which could be, let's see how I'm doing that. Because then I'll run sometimes and it doesn't. Some weird let's see. Let's look at distribution. Let's see, color based on age. So let's see if there are other things that, what you can do on this, of course, is go up here and split top bottom and add under inspectors, geometry spreadsheet. So we can do it on P. Let's see what, now this is interesting. When we redo it, it cleans it up and we get the different colors. But we can even change this to P and then get a different set of colors. So now the other thing that, let's see, close. We want to close this out. So we're gonna, all right. Now, there's another thing you can do, and let's see if this is gonna work. We're going to throw down a cube. All right here. And we're gonna take this. Now this is also important. In the older versions, I believe the collision type stuff was under particles. I'm talking about the ground plane, the static object, these items. So you may see it say go under particles and look for these. No, now it's under collisions. So let's select our box and select static object. And let's go back here, start over. And hit return. Now let's see if it did anything. Yeah, so see it added all this stuff, collision source, made it a collision object. So let's see what happens now when we send down these. Notice they should be, well, it's not quite working because these should be colliding. Now, you know why? I'll tell you why. Let's stop this. And let's go back into here and into our .NET. And now let's see if that will work. I haven't tried this. Yeah, this is, you see what's going on now? Now that it's merged in, you can see that things aren't going into it. They're going on, or they're bouncing off of it. So that's how you would add another static object. Probably this kind of looks like, this is an example that's used all the time where they're like Cheerios and then you make like a little bowl, make that a static object and so forth. So that is how you do these types of things. This is how you're going to get collisions, and now you can, again, you can export it if you get as .rs files. If you're using Redshift, you can export it as an Alembic. And I believe you might be able to bring the colors into an Alembic as well, although I have not tried it with this example. So anyway, hopefully this has been helpful. Hopefully you've learned something about, now you can have, A, you can make objects in any shape, and B, if you're going to want collisions, you can use the RDB solver rather than the pop solver. Now, we saw the format with that the shells generate, and I believe you can adjust that as well to get. And oh, I see what this is doing. When I made it a rigid body object, it added this to here, but it didn't. This is really weird. I don't even think we need this. Actually, I think what we can do is get rid of all this mess. And since we have it going to the box anyway, I think this will still work. I don't think we need it. Yeah, you can see it's still working here. And I created materials. Let's see, there's no material on the box. But let's have a look, so just so you can see. And it's rendering, right? You can see how everything is not, oh, this. See, when you look at this, it looks like something's going in. But you're also seeing, this is interesting. Because when you look here, you got some of these partially in. And here you don't see. You'd probably want to experiment with more. See, you're getting a different picture here. Oh, let's try, make sure we have the same camera angle. That's another thing you can do. And very interesting. You're getting slightly different results on here than on our image here. Actually, be having some weirdness with the output of this. Like, this is supposed to be bricks, and I haven't gotten it to look at bricks. You see this one? Okay. And you got, the block doesn't even look like it's the same shape. And you got one look like, you don't see any look like they're going in here. So anyway, this is a Redshift weirdness that I'm not sure why it's happening like that. But anyway, hopefully this has been helpful. And again, this is, you can, especially if you make an Alembic, you can take it anywhere and use this particle simulation that's now turned into where you've now instanced it, which means you are connecting it to a geometry. And then we went the next step and we added the rigid body solver, which means that it'll respond to collisions and actually be able to collide on static objects. Oh, yeah, this is weird. Look at this here. You got these two look like they're partially inside, and you don't see any of that here. So yeah, this is giving me a weird output. And look at these. They're not smooth. They kind of look jumbled. This is a weird output I'm getting here. So anyway, thank you for watching, and I will speak to you next time. Take care.